Our brains are amazing. They are like supercomputers inside our heads. Our brains are made up of billions of tiny cells called neurons. These neurons talk to each other using electrical signals. When we learn new things or have new experiences, our neurons make new connections. That's how our brains grow and change. Have you ever watched a flock of birds flying together? They move as one like a beautiful dance in the sky. That's collective intelligence. It's when many minds work together as one.
Our brains are like networks, just like the internet. Each neuron is connected to many other neurons, forming pathways for information to travel. When we think, learn, or do anything, signals zip around these pathways. These brain networks are constantly changing and adapting. This allows us to learn new things, solve problems, and interact with the world around us. They help us to understand and respond to our environment. Our brains also produce brainwaves, which are like rhythms or patterns of electrical activity. Scientists can study these brainwaves to understand how our brains work, especially when we work together.
Scientists have invented amazing tools to study our brains in action. These tools allow us to peek inside our heads and see how our brains work in real time, which is truly fascinating. One of these tools is called EEG, which stands for electroencephalography. It's like a cap with sensors that can read brainwaves from outside our heads. These sensors pick up electrical activity in the brain, allowing scientists to see what's happening inside without any invasive procedures. Another tool is called fMRI, or functional magnetic resonance imaging. It takes detailed pictures of our brains to see which parts are active when we think or do different tasks. This helps us understand the brain's structure and function in great detail. These tools are helping scientists understand how our brains work together in groups. By studying brain activity in social settings, researchers can learn how we communicate, collaborate, and solve problems together. Imagine a group of people wearing EEG caps while solving a puzzle together. This setup allows scientists to observe how their brainwaves sync up as they collaborate and work towards a common goal. Scientists can see their brainwaves syncing up as they collaborate. This synchronization can tell us a lot about how people connect and interact on a neurological level. These tools also help us to understand how our brains change and adapt over time. By monitoring brain activity over long periods, researchers can see how learning and experiences shape our neural pathways. This knowledge can help us to improve learning and problem solving.